we will now dive into our course. And as you know right now, we are in qualitative research methods, and we are looking into quantitative data analysis. So if you remember last time, we were discussing descriptive statistics. So at this point, if you were there or were able to catch up with the session, you already should know the difference between descriptive statistics and inferential statistics. So knowing this difference is key. And you know that when we are using quantitative data, we need to know, and we need to be sure that the conclusions we are finally getting from the data are valid. And for that, we need to talk about the shape of the data. How can we interpret all of these quantitative data that we have? So basically, we have these two main ways with the statistics. And we will discuss a little bit more about it. Let me go to full screen. Do you have the full screen now? Or are you looking at a split screen?
That is the split screen, I think.
Okay, so let me change the view. This is not the way to do it. Let me do it again. What about now?
Now we see your screen. Now we have the full screen.
Okay, the full screen. Okay, great. So let's continue discussing about descriptive statistics. And remember, the goal here is to know what the data we are collecting from so we have a sample of data from our population, right? So how can we make sense of this data when we have quantitative data? So as you know already, we already discussed this, we use statistics, we use these two types of statistics. When we are using descriptive statistics, we are looking into the data that we have without making inference. This is the field of specifically inferential statistics, and there we are talking about the probability of the data being like this in a broader population. So with descriptive statistic, we are just talking about the sample that we have without making any assumptions. So for descriptive statistics, we are trying to describe the phenomena, and we are using tables and graphs. So as we discussed last time, there are two main ways to use descriptive statistics. The first one is by organizing scores in this kind of graphs that we already discussed, or by summarizing scores. That is calculating mean values, a standard deviation, the variance of the data. So what information is the data actually telling us? So we already discussed all of this in the previous session, but here, just for you to remember, this is the bell curve, the normality distribution of our sample data. So here you know why having a normal distribution is really important when you are looking into quantitative data. So as you can see here, it's very interesting how here you have the mean of the population in this graph, and then you have one standard deviation to the left and one standard deviation to the right. So within one standard deviation, you have almost 70% of the data. So this is why it's really, really important to actually have a normal distribution, because with this normal distribution, you are able to make like some clear, you are able to have a clear idea of what the data is telling you. So this is why descriptive statistics is really important, is actually the basis of inferential statistics. So we already discussed all of this. main measures of central tendency, we already discussed this, are the mean, the median, and the model. And the measures of variability, we have the range, we have the variance, and we have the standard deviation. I already told you the most important one that you should keep track is the standard deviation, and we will continue talking about that in our following sessions. So this is all about the shape of our data and how we can make sense of this data. We already discussed all of this last session. I'm just making a recapitulation for you. So you are in the same page regarding why it is important to have a normal distribution in our variables and why it is important to measure it. If we don't have a normal distribution, we are violating the assumption of normality. So we have certain statistical assumptions that we need to meet in order to run inferential statistics. Usually, the inferential statistics that are more common are regression analysis, for example, linear regression, multiple regression. We have ANOVAs, we have t-tests, for example. We have factor analysis. We have different kinds of inferential statistics, and we will look into that in our next session next month. However, this session, I would like you to focus on the assumptions of normality. So we have different assumptions that we need to meet in order to run the inferential stats. Most papers in psychology are using inferential statistics in order to make sense of their data. However, not all of them are meeting the requirement of taking a look at the shape of the data. So we don't know if they have a normal distribution or not. And if they are not telling us if they met the normal distribution and the variables, we are not able to see if we can trust the statistical analysis. This is why it's really, really important for me to know about statistical assumptions. So the one that we are looking at right now is normality, the assumption of normality, but we have other assumptions like linearity or homoscedasticity, and we will look into those in the next meeting. Right now, we will talking about the assumption of normality. So because having a normal distribution is so important, we already discussed how to look into it. Actually, I remember Matthias was great at looking at a QQ plot. So he was able to, just looking at the QQ plot, being able to tell us which distribution was normal. So here, this is a QQ plot. It is called QQ plot because it is quantile versus quantiles. So we have theoretical quantiles plot with a normal distribution, and then we have the quantiles of our sample plotted. So if you have a distribution that is not normal, there is a skew or there is kurtotic, and we will discuss these terms today. So you can see the QQ plot going away from the theoretical line that should be close to. So this is a QQ plot, and it's a great way to look for normality. The other way is an histogram, which is this, but sometimes because the deviations are not that obvious, sometimes it is not as easy to look into the normality, but it will depend on your needs, because actually there is another plot that is really important, which is a box plot. So the box plot, which looks like this, is actually also really helpful for looking into the normal distribution. This is a box plot. So we will talk about it today, but here, like this is supposed to be centered. Here, for example, you can see how a normally distributed data look in a box plot. It should look like this. This is the median. This is the exact middle of our data. And then this is 50% of the data. This is the other 50%. and this is the 25% percentile, and this is the other 25 percentile. So this is the 100% of your data. It should look like this if it's normally distributed. If it doesn't look like this, if it's going towards one side, for example, this is shorter than this, or the opposite, this means that you don't have a normal distribution. Your distribution is skewed. So if it's a little bit more to the left, is a positive skew, or the other way is a negative skew. So as you can see here, I like this image because you can see here how the histogram look. So if you are looking at the shape of the data with an histogram, it will look like this. It is going towards the left, and here is going towards the right, and this is the normal distribution. So I think this is a great way to look at the shape of the data, the bell shape. You should have the bell shape, or you can use the box plot, which I think is great because using the box plot will give you the outliers. So the outliers are really important in your sample distribution because sometimes you have more or less a normal distribution, but you have some data that are going like really, really high or really, really low. So these data are called outliers, and we should cut them. If you have outliers, a lot of outliers in your data, it means something went wrong. It means maybe people didn't understood the question and they were answering something else. Maybe when you were like doing the input of the data manually, maybe something went wrong, or when you were copy pasting your data, maybe something went wrong. Having a lot of outliers is really, really bad. It will damage your distribution, and it will prevent you from using the statistical analysis that you want to run. So we don't like the outliers, and if you have a plot that will show you the outliers, it's great. This is why I will recommend using box plot in order to look into the distribution of your data. So you can use the box plot, for example, in order to look into the outliers. And if you identify outliers, there are many different ways to address this. So you need to find out what is the origin of this data that is so far, and then make a decision regarding how to fix it. But you cannot go just like that and run the statistical analysis. And this is why it is very, very important for you to look into the normality of your sample. So as I said it before, mainly there are two ways on how your distribution could be not normal, and one of them is being skewed. So as you can see here, being skewed is being too much to the left or too much to the right. This is a measure of location of your data. If your data is in the first quantile, so you will have a positive skew, as you can see here. So in the first quantile, you have more data than in the middle. So there you will have a positive skew, and the opposite will happen for a negative skew. So skewness is one of the things that can go wrong with your data. The other thing that can go wrong with your data is to have kurtosis. So kurtosis is a measure related to the variation of your data, not where your data is located, which was the case of skewness, but a measure of how much is the variation of your data. And here is where the outliers are really messing up your normal distribution. If you have a lot of outliers, it will pull the curve, and it will give you like one of these two settings where you have a really flat line. Then you will have negative kurtosis. It is also called a platykurtic curve, or the opposite. Maybe you can have it too spiky. If you have it too spiky, then you have a lot of layers here, and then you have a leptokurtic curve, which is positive kurtotic. None of, like, not the platykurtic or leptokurtic are good things. So you don't want any of that. You want to have a mesokurtic distribution, which is the normal distribution, the bell shape, right? So this is about the variation of your data. If you have a lot of layers, your data will look, imagine if we make an histogram and it will look flat. It will look like this. Or if you have leptokurtic, it will look pikey like this. So here you can see if you have kurtosis or not. So you have to be careful of both things, and you can use like the QQ plots and the box plots in order to look into that. So it is very important for you to know how to explore it. So here, this this box plot, I was telling you, it should look center. It should look like this. Here you have the 50% of your data, and then you have the other 25, and the other 25 here. It should look like this, like the other that I show you, like this. So box plot is a great way to look at it. And the QQ plot, as we already discussed, you have here an example. So mesokurtic is the normal distribution. This is the bell shape, is the thing we want to see. As you see, is really close in the QQ plot, is really close to the hypothetical line, and the other ones are a bit off, right? So being the leptokurtic, like really heavy tails. So the heavy tails, we say that when it's going far away from the hypothetical normal distribution. So here is how you can use and interpret QQ plots and box plots. So at this point, I don't know if you have questions regarding, this is a graphical way to explore the normality of your data. If you're looking for skewness or kurtosis, but it's not the only way. You can also use maths, and only you have the formulas here, and you will have a number, and then you can compare this number with a cutoff that we use in psychology, and then you will know if your sample is normally distributed or not. Here, I put you an example of how to use it, how to do it with SPSS. So in SPSS, you go to descriptive statistics and then ask for the frequencies. And right here, you can click these boxes, show me skewness and kurtosis, and then you will have the results. And it is really easy. Here, for example, I have the thresholds for you. You must know that skewness should be between minus 0.05 and go up to 0.05. So if it goes below this or more than this, then your distribution will be skewed. So this is the threshold that you have. And regarding kurtosis, it should be more or less close to 3, the number that you will get for this way of exploring. So here, for example, I get you 2 samples. So here is a normal distribution, and you can see here that the skewness that is reported is 0.03, which is within the threshold. This means it is not skew. And kurtotic, like, is 2.96, which is close to 3. This means it is not kurtotic. So this is a normal distribution. In this case, like, skewness is 0.06. So it's a bit skew, right? And it is very kurtotic. Can you see how far it's going from 3? So this means it's really spiky, as we can see in the histogram, right? So you can either use the graphical representations to look for normality, or you can use the software, the statistical software, in order to get a number and then to know if you are meeting the normality or not. Okay, so before continuing, I have some hands. I think Amber was first.
Yeah, so so I understand these different models that you've given us, but like, I have one general question and one kind of specific question, but the general question is like, why should we expect human behavior to fall according to a bell curve? Or like, why should we think that the bell curve is sort of actually a normal distribution in real life of how things play out? And then the other question is like, so what if you get data that is skewed or that is kurtotic or whatever? What does that mean practically? Does that mean that that it has no predictive value, that it has no explanatory value? Like, because we're just talking about like the data is skewed, and I kind of want to know like, so what?
Yeah, perfect.
What's the upshot of that?
Yeah, definitely. Both great questions, Amber. Thank you. So, first of all, we are talking here about the sample distribution of our data. And this is different from the actual frequency distribution of the population. So we are using samples in order to determine where the mean is. So technically here in statistics, we have a theorem, the central limit theorem, which states that as your sample is getting larger and larger and larger, because you are averaging all the data that you're getting, at some point, all the distributions will actually be normal. It's, for example, let me give you an example. Let's say I will ask you about your height. And let's say you are telling me, I am 168, and then maybe Andrew can say, I am 185, for example. And then we have a huge difference between you and Andrew, for example. And then we input Sarah's height or Matthias' height, and then we have like a less extreme difference, but still a big difference, right? Because my sample is just 4 persons or 5 persons. But if I sample 100 people, then it is more likely that I will average out the differences, Amber. And then if I sample 1,000, even more so the case. If I sample 10,000, even more so. So this central limit theorem, so please write it down and look at it. It's great. Well, it is really useful in statistics because it can tell you, you know what? If your sample is bigger than 30, 30 is the limit in the central limit theory. If your sample is bigger than 30, then you are fine. So this is why we love it in psychology. However, we are expecting this to be the case. We already know that things like IQ, like, for example, height, like most phenomena that we have, either natural or psychological, most of them actually follow the normal distribution. One that doesn't follow it is, for example, income. Income, it could be like really, really skewed, like with some people, like most people having an average salary, and then we have millionaires having a lot of money, right? So this is one that we have to do if we want to analyze this kind of data. And we are going here to your second question. What can we do? We can do many things. First of all, we can do a transformation. We can perform some mathematical calculations in order to get rid of these gaps between the data, in order to not to have the outliers influence that badly the assumption of normality. This is one thing we can do. So there are many different things. One thing is making a transformation of your data. Other method is having a bootstrapping. Bootstrapping is also a mathematical procedure where you are actually calculating thousands of samples that are computed with the samples that you are getting. So it is coming out, the statistical software is coming out with hypothetical samples, thousands and thousands of them, in order to compute them all together and to see different scenarios, hundreds of different scenarios, and to see what kind of information we can draw from the data. So we have transformations, we have bootstrapping, right? We have different ways to go. And the important one, because to be honest with you, like in many cases with the variables, transformations don't work. For example, one transformation is squaring everything, and sometimes squaring it, like the problem goes away, but many times they don't work. So if I want to go textbook, I have to tell you transformation, but if I want to tell you regarding everybody's experience, transformations, they are not very useful. But the way that you should go is going to a different kind of statistical analysis. You have to go to non-parametric tests. And this is the key. This is the key of you knowing this, because if your variables were skew or kurtotic, then you cannot use the normal statistics. If you have residuals that are skew or kurtotic, you cannot use regression in order to calculate your stats. But you have other ways, you have other tests that doesn't have the assumption of normality. So these other mathematical equations, they don't account for this, and you will be able to draw good conclusions from the data. But in order to determine which test, you have to use either parametric or non-parametric. First, you need to test for your normality. So this is the way you can go about it, Amber. So great questions. And I will ask you to feel free after any session, if you still have some question about it, or if you want to go deeper into a specific concept, feel free to email me, and we can continue clarifying this concept for you. Obviously, actually, my slides from last year, I already had slides with this information, but it was really, really long. And then I think I was overwhelming people with a lot of stats, and I took it away. But it's great that you were interested and we were able to discuss it. And if you need more information, we can continue going into these things. Okay, so I think, Moritz, I think Moritz wanted to say something.
Yes, I had a question, but you answered it already, Gina. Thank you.
Okay.
Yeah.
So let me tell you, I am really, really like happy to see you, that you are interested and you are getting the main points of this session. So today will be today is a happy day for me. It's great that you have these kind of questions. Okay, so we are already finishing this session today. So just to close it, statistical assumptions are really, really important if we want to look into the reproducibility in psychology. So if we want to have valid research, we need to care about these things. So as you can see here in this paper, and I left this paper in the materials for you in Moodle in order to look at it. But as you can see here, and the second thing that these authors were detecting regarding issues in reproducibility in research in psychology, they are reporting that not all the psychological variables meet the normal distribution hypothesis. So we have clear violations in the papers, and this is the issue why psychology could be struggling sometimes. For example, if we go once again into the paper that we already analyzed regarding character growth following the first wave of COVID, I don't know if you remember, we already looked into this paper, we already looked into the claims, we were already looking at what kind of information they are giving you, the hypotheses they have, the variables they assess, the instruments they use. We even were looking into how valid and how reliable these instruments they use were. So right now, I will ask you to come back to this paper and now to look at the measures of central tendency that they are giving you. Like, what are the means they are reporting? What are the standard deviation they are reporting? Or you can also look into the frequency distributions they are reporting, or if normality was actually assessed in this paper. You need to do all of these things in order to evaluate the quality of psychological research. And this is why it is very, very important for me to do it. Here, for example, I have this screenshot of this paper, and I really like that these authors, they are actually showing you descriptive statistics. We have here the frequency of the answers regarding perceived changes in oneself in character strengths following COVID crisis. So they are giving you the descriptive statistics. This is great. Most of the papers, they won't tell you the frequencies, like how much were they reporting no change, which we have here in gray. This is no change. This is some change. And this is like less, like you have less the character that they are assessing, less than COVID. In this case, for example, spirituality. So here you can see it here with descriptive statistic, and I love it. And this is one of the reasons why I give you this paper in the first place. So this is a strength of this paper. However, the second part, they actually didn't assess for normality. They are not reporting the shape of the data of their variables. We don't have any report about how it was, which I think is a weakness, because not letting us know about the shape of their data, it doesn't allow us to have really elements in order to judge if we can trust the results or not. So sadly, they didn't assess for normality, or if they did, they are not reporting it, which I don't think it is the case, because if you are running these stats and you are getting good results, I mean, a normal distribution, usually you are reporting it because you are so happy because everything is good with your data. So sadly, they were unable to show it. And let me show you this other paper that I think is great for you to know more about this issue in psychology. And this paper, it is a systematic review of the common misconceptions in papers in psychology. So let me try to share this. Let's see here, share here. Okay. So this paper, I also left this paper in your materials for this class. So here they are looking into the regressions assumptions in clinical psychology research practice. So it is great because regression analysis are really common in psychological research. Actually, they are running regression analysis in the paper we were looking about the character strengths. And they are looking like they are conducting a systematic review of a lot of papers trying to see how the assumptions were met or not, or if they were using misconceptions to run the statistical analysis. So sadly, as you can see here, they are reporting that 92% of all the papers using a linear regression were unclear about their assumption checks violating APA recommendations. So sad but true. It is the case that we see this. And now for me, it is really, really important for you to know this, to know that you have to look into this in the papers in order to really have a good idea and see if you can trust the paper or not. Let me tell you already. Do you see the PowerPoint on screen now? Do you see the full screen of the PowerPoint?
Now we do.
Yeah.
There was a lady on a beach for a second.
Yeah, yeah. It's like being in that
Nice.
beach is my goal. Is my goal in life. So I have it in the screen. Yeah. Okay. So I will ask you, like as I told you before, my work with you is to tell you about research methods in psychology, which methods we have, how we use them, and then what kind of bias we can actually we have to be careful with, right? In order for you to be better consumers of psychological research. So in this line of thought, I will ask you for the following assignment. This is an assignment that you will send. You will send it to me. Actually, I will post it in Moodle, and you will have it with the papers attached and with the deadline. However, I would like to tell you already, I will ask you to make a comprehensive evaluation of 2 papers. One of the papers is the one that we already discussed up to a point, the character growth following collective events. And the other one is called stress-related growth among diabetic outpatients. So this second one is really interesting because they are using structural modeling equations in order to test a psychological model. So I think both are great practice for you to see how much you can trust research. And the deadline for you to send me this analysis that you will do, it is January 10th. So you have many months to do it. I will send you the 2 papers, and I will actually provide a guide for you. I have a guide, so I don't know if you are looking at the PowerPoint, at the Word document right now. No, let me change the share mode. Let's go to this. Okay, what about now? Yes, okay. So here I made for you a guide of how to evaluate papers in psychology. I divide this guide into how to look into the information in the title and the abstract, how to evaluate the introduction, how to evaluate the methods, how to evaluate how they are presenting the results. And for example, here in the results, obviously looking about the statistical assumptions and seeing if you can actually use parametric or non-parametric tests. So here you have like a bullet point, like go to, in order to, while you are reading the paper, looking into the design, the participants, the measures, the procedure, are they describing them or not? Is it an ethical instrument they are using? Are they reporting the ethics? Are they reporting the open science? Do they pre-register? Do they have hypotheses? Do they have research questions in the paper, And with all of this information, the more points they have, the better the research it is. Okay? So I would like you to do this. I don't know if you have a question regarding the assignment. I will send you everything by email, so you have it. I just wanted to introduce this assignment to you. I don't know if you have any question. Easy peasy, huh? Easy thing to do. Like, I want you to be experts regarding looking into issues with papers in psychology.
I don't know if it'll be easy, but it sounds clear. So
yeah. And if you have some questions, feel free to send me an email in order to clarify the task and also to help you. Like, we will continue looking these papers in the other sessions. So I will already giving you some of the information. Like right now, they didn't assess for normality in the paper, so you already know the answer to that. So it's a work that we are doing like during the whole course, but at the end, I would like to see how much were you able to catch in order to evaluate like how much you were able to actually grasp these concepts that we are discussing in the course. So this is why I think it's a fun task, and it will be really helpful for you to consume, like from now on, to consume papers in psychology. Okay, so I think it was a great session. I'm pretty happy with your questions. I don't know if you have some more or if we will call it the day.
Good to see everybody.
Okay. Yeah, have a nice weekend.
Thank
See
you,
you.
Gina.
Take care.
You're welcome.
Thank you, Gina.
Bye.
See ya.
bye, everyone.
See you.